Hello and welcome to R for Civil Engineers. This is our Microcourse-I, where we focus on programming concepts and numerical methods. In the last video, we saw how to install R in RStudio. So what we are going to do is we are going to be looking at some functionality of RStudio in this video, and I'm going to motivate this exploration of RStudio functionality using a simple example that you would typically encounter in your early physics or statics classes in civil engineering. So the problem of interest to us is the Red Pyramid of Dashur near Cairo, Egypt. This is, by the way, the largest of the pyramids that are out there, and it is also believed to be the first engineering attempt to construct a smooth-sided pyramid. It was built around circa 2070 BCE. It has a height of 105 meters and a base width of 220 meters. What we want to do is calculate the force exerted by the atmosphere on the pyramid. The atmospheric pressure we know is roughly around 101.3 kilopascals, and this pressure is exerted on all faces of the pyramid that are exposed to the atmosphere. So we can write force is equal to pressure times the area. The pressure here is the barometric pressure, and then the area is the area that is exposed to the atmosphere. So that would be each of the four triangles. You're seeing two in this figure, so there are two similar triangles on the other side. So it is 4 times the area of each triangle, which is half times base times height, which leads us to 2 times the base times height. So we know the base, we know the height, we know the pressure. So we need to calculate the force that's being exerted by the atmosphere on this pyramid. We want to implement this problem in RStudio just to get your feet wet in using RStudio. When you open RStudio, you're going to see 3 panels. The area is divided into 3 panels. The first panel to the left has your console, and you will notice that there is R 4.3.2. This is the version of R that we are using in the back end. RStudio, as you know, is the interactive development environment that works in the front end. So everything, all the magic with R happens at this console. So if we write commands or we give some commands to R to do something, those get executed at this command prompt. So what we want to do is we want to first define a few variables. So the first variable that we want to define is our atmospheric pressure. So I'm gonna, at the prompt, write P atmosphere, and this is the name of the variable. And I'm gonna use the assignment operator, and the assignment operator is obtained by putting less than sign and a dash. And I want to, on the right hand side of that assignment operator, I want to put 101.3. This is kilopascals, so I want to multiply it times 1000 to make it into pascals. So notice that P atmosphere is a variable or an object, and what we want to do is we want to perform this calculation that's on the right hand side and assign it to this variable called P atmosphere. So we have assigned this, and we are going to hit enter. And then I also know that my height, H, is 105 meters. So I'm going to assign 105. Notice I'm not putting any units because all my units are consistent. So I'm not doing any unit conversions or putting any units, but the units are implicit. And I also know that my base width is 220 meters. So I put 220. So finally, what I want to do is I want to calculate my area, A, and this area is nothing but 2 times base times the height. So this would be very similar to putting a formula in a spreadsheet. We have our variable h, we have our variable b, so we are multiplying 2 times b times h. One thing to keep in mind is that R is case sensitive, which means uppercase A and lowercase a are two separate type of variables, so they cannot be mixed in math. So we have to be very careful when we use R in that, we need to make sure the variables are written in the same way that we have defined them. So once I do my area calculation, finally what I want to do is calculate my force, and my force is nothing but P atmosphere. So remember, I wrote my P atmosphere with a capital P and a lowercase atm, so that's what I need to do, times the area. So once it's done, all the calculations have been made. Now I need to find out what the value of force is. To do that, I can simply use the print command and say F. And it gives me, this is the force in newtons. So if I want this force to be, say, in kilonewtons, I can divide it by 1,000. Actually, let me go and put another 0 there. So it is so many kilonewtons. Actually, if I want to do 10 raised to the power of 6, so that would be meganewtons. So 4680 meganewtons is the atmospheric pressure that is acting on these walls of this pyramid. Clearly, if the walls of the pyramid were not able to withstand this atmospheric pressure, they would be crumbled, and they would fall apart and then fall in. But clearly, the ancient engineers in Egypt built it such a way that it can withstand the atmospheric loading that is being exerted on it on all the three walls. A few other things to show in R is this is how we can put line by line things and then do calculations at the command line. Okay, and if you notice on the right hand side, there is this environment tab. And what this environment tab tells you all the values that you have calculated or assigned to variables. So you have a value of A. This was assigned, this was calculated. We calculated that value to be 46,200. B was what we had assigned. F is what we calculated. H is what we assigned. P is atmosphere. So it keeps track of all the variables, and then it keeps track of the corresponding values. This is very nifty because you can go, for example, if I'm doing a calculation, I want to know what the intermediate values are, you can pick them here. Of course, as you see, if I were to redo these calculations for several pyramids, it doesn't make sense for me to go and put these things line by line. So to avoid that, what we can do is we can put in a script. To put in a script, go to the very top and you will notice this plus sign here. And if you hover around it, it'll say a new file. So if I click on it, it opens and gives you a variety of different files that you can open using RStudio. The script, the one that is the file type that is of interest to us now is this R script. So I'm going to open this R script, and when I open the R script, it opens a new editor, if you may, that where I can type my script. So script, as I told you, is basically a text file that stores a list of R commands. Okay, and when you write scripts because you want to reuse that code again at some other point, or you want to document it and present it to somebody else, your client or your professor. So one thing you need to get into the habit of is writing comments in your code. And in R, we use the hash sign to put a comment and say this problem computes the force, the atmospheric force on the red pyramid. You may also want to put a date, time, and other things. Usually it is good for you to put your name and other things, because while this code is fairly simple, more complex codes that you give to your colleagues or to your batchmates or to your clients, they may not understand it. So having your contact information right there gives them an idea who wrote this code and when was it written, where was it written, and they might get in touch with you if they have any questions. So the first thing we want to do here is we want to define what is known. So what is known for us is P atmosphere, and this is equal to 101.3 times 1000. Again, I can put a comment here and say atmospheric barometric pressure in pascals, because I'm multiplying it by 1000. H is the height, and height we know is 105. This is height of the pyramid in meters. So you can see that I can add a lot more. Base is 220, and then base of the pyramid in meters. That should also be lowercase meters. And then I'm going to do my intermediate calculation A. A is nothing but 2 times H times B. And then my F is equal to, or assigned to be, P atmosphere times A. Again, I can comment this and say surface area of the pyramid exposed to atmosphere, and then P atmosphere times T. This is the force exerted by the atmosphere, okay, in newtons. And of course, I didn't put the area here, but you could also put square meters, okay? So if I want to print this result, you can say print the force exerted is, and then I can print F. So I put a comma. So it will print this text here, and then it will print the value of F. So let's see how this code would run. So once we write the code, we select all of this, and then we go here to run, and then click on it, and it will write this, and it says that there is an error in the words that it is not writing that force exerted is correctly. So we need to figure out how to do this print. I can fire up ChatGPT and ask how to do that. So once I'm in ChatGPT, I can say, how do I include text and a variable value in print statement in R? Show me an example. So it is saying that I can use the paste value, and then, or I can use the cat value. So it gives me two different ways of doing it. So there is this force, and it's saying print, paste, the value of my variable is, and it gives me the value of the variable. So I can simply take this and go back, and here all I have to do is I'm going to comment this line so that I can see how this is being done. So all I need to do is do a paste, and the first thing is force, and then my variable, so which is f. So first I have to paste it, and then I have to run this. So once I have done that, you can run this problem again to see if it worked, and this time it did. So the force exerted is 468,006,000 newtons. And of course I can also include, I can experiment here and put newtons, and I'm going to put a space here, and if I run that code again, now it's saying the force exerted is 46,000, and then it gave me that space and added newtons to it. So you can see how you can use ChatGPT alongside your R to do coding. So this is a simple example, and once you have this done, you can go File and Save Things. It'll open and say where you want to save. You can go ahead and save it wherever you want with a name, and it'll store it with my first R code, and then I can store it wherever I want. For example, if I want to store it in desktop, I can just say save, and it will save it there in the desktop, and you have it for you. Okay. So once you're done with R, and let's say you're trying to close R, you can just click on that X button on the top right, and it'll close, and it'll say, do you want to save the workspace image to /back.rdata? So what this rdata does is it stores everything that's in the console. Typically I don't save it because the console is where the calculations have been made, but if you want to save it, you can save that too. I'll just say don't save and move on. We'll explore much involved examples in coming lectures, but this should hopefully give you a start to R programming. In the next video, I'm going to talk about data structures and start getting into talking about why we need to know data structures to do things a bit more complicated than what we did today. Till then, take care, stay safe, and goodbye.